Now recall that when we are given a right triangle, we can use the Pythagorean theorem and the SOHCAHTOA. But when you are given oblique triangles, meaning triangles that are not right, then you will have to use either the law of sines or the law of cosines. Now, what does the law of sines state? Now, the law of sines states, again, that the side of an angle of a triangle divided by its opposite side is equal to the sine of another angle divided by its opposite side. So, for a triangle with sides A, B, and C, and opposite angles A, B, and angle C, the following are true. So, sine A over A is equal to sine B over B equals sine C over C. So the sine of an angle over its opposite side will be equal to the sine of another angle over its opposite side and equal to the sine of the third angle over its opposite side. Or we can express this as A over sine A equals B over sine B equals C over sine C. So the ratio of the sine of an angle in a triangle to its opposite side is equal to the ratio of the sines of the other two angles to their opposite sides. Now take note also of the two cases where the law of sines apply. So we have case 1 when we are given two angles in one side, and this is called the ASA case or SAA case. And case 2, when we are given two sides and an angle opposite one of these sides. And this is known as the SSA case or the ambiguous case. Now, last meeting, we have discussed case 1, when two angles and one side are given, or the SAA or ASA case. This time, let's proceed with case 2, when two sides and an angle opposite one of these sides are given, or this is known as the SSA case or the ambiguous case. Now let's look at the cases that fall under case 2 or the ambiguous case. So this is the first scenario that can happen. So case 1, in triangle ABC, angle A is 38 degrees, side A is 20, and B is 42 units. Okay. Now here notice that we are given two sides, sides A and B, and an angle, which is this angle A, which is opposite side A. So we're given two sides and an angle opposite one of these two sides. Remember, angle A here is opposite side A. So clearly, this case falls under case 2, the SSA case or the ambiguous case. Now, let us construct the triangle by constructing A, which is equal to 38 degrees. On one side of A, cut off B equals 42 and a radius equal to 20. And then draw an arc. Alright. Now, here is angle A, here is side B, which is 42 units. Okay. Now, so from A to C, that's side B. Now, with C as center and a radius equal to 20, draw an arc. So from this point C, which is the center, we draw a radius, this line here. This is equal to 20. Okay. And this will now be side A, which is equal to 20. Now here, draw an arc. So this is the arc. Now notice that the arc here will not even touch this other side of A. This is the other side of A. The arc is only up to here. So it's not even going to reach this other side of A. And therefore, no triangle is formed. That means that there is no solution. So if no triangle will be formed, then we can say that there is no solution. Now let's try to look at the second case, the second scenario. So here, in this case, in this example, in the same triangle, make A, side A equals 30 as the radius. This time, the arc with C as the center and A equals 30 as radius will intersect the second side of A at 2 points. Those 2 points are B and B prime. So let's look at the figure. Okay, so we have the same triangle ABC. This is the C, the center. So we draw A, which is equal to 30. So this side here is side A, that's 30. Now, from here to here, this one will also be another A, which is also 30. Okay. Now, notice that the radius, this CB and CB prime, let's call it CB and CB prime, this radius will intersect this second side of A at 2 points. The second side of A is this one, AB. The first side of A is this AC. The second side of A is this AB. Now, again, from the center, you draw a radius with 30 as the length. So this one, this side A is equal to 30. And this is another radius that we can draw, which is also 30 units. Okay, so the points of intersection here are points B and B prime. The point of intersection of the center and the second side of A. Okay, so the center, this radius here intersected the second side of A at points B and B prime. Now, as we can see, two triangles are formed. What are those two triangles that are formed here? We have triangle ACB, this bigger triangle, and this other triangle ACB prime, if you can see this. So triangle ACB, this bigger triangle, and triangle ACB prime. Okay. Now both CB and CB prime here are solutions. Okay, because they both formed a triangle. Now, since two triangles are formed here, therefore, it means that we will have two solutions. So, this case produces two solutions. Why two solutions? Because two triangles were formed here. Now, let's try solving triangle ACB. Okay, so this is our figure. Let's try solving triangle ACB. Now first, let us solve for angle B. Okay, so to solve for angle B, we can use this proportion. Sine A over A equals sine B over B. Why this? Because angle A is given, side A is given, side B is given, and the only unknown here is angle B. So if we substitute the values, then we will have sine 38 degrees over 30 equals sine B over 42. So by cross multiplication and dividing both sides by 30, we will have sine B equals 42 sine 38 degrees over 30. And that will give us a value of 0.8619. Now, to solve for B, for angle B, then we will get the sine inverse. So B here will be equal to the sine inverse of, you can use this, 42 sine 38 degrees over 30, and that will give us a value of 59.53 degrees or 59 degrees 32 minutes. So now we have angle A, we have angle B. Now let's try solving for angle C. So if B is equal to 59.53 degrees, then angle C will just be equal to 180 degrees minus the two angles, which is 38 and 59.53 degrees. So therefore, angle C will be equal to 82.47 degrees or 82 degrees 28 minutes. Okay. So we now have angle A, angle B, and angle C. What other parts of the triangle are or is missing? So here we have side A, we have side B. So this side here is missing. So this side is side AB, or we can also call it side C. So to solve for the length of side AB, we can use this proportion, sine C, this is angle C, over the side opposite angle C. If this is angle C, the side opposite angle C is AB, which is the side that we're looking for. This is equal to sine A over A. Because angle A is given, side A is also given. So if we substitute the values, we will have this. Sine 82.47 degrees over AB equals sine 38 degrees over 30. So by cross multiplication and dividing both sides by sine 38 degrees, we will have AB equals 30 times sine 82.47 degrees all over sine 38 degrees. And that will give us a value of 48.31. So we were able to solve for triangle ACB, the bigger triangle. Remember, when we say solve a triangle, that means we will find all the three angles and all the three sides. Now let us also solve for the other triangle formed, this triangle ACB prime. So let's try solving for that as well. So let us try. So first, let us solve for angle B prime. Okay. Now, since the sine of an angle and its supplement are equal, I hope you're able to figure this out from activity 1.3. I ask you to answer in your printed module. So from there, you will find that the sine of an angle and its supplement are equal. Then, therefore, angle B prime will be equal to 180 degrees minus 59.53 degrees. And that will give us angle B prime is equal to 120.47 degrees or 120 degrees and 28 minutes. Now let's try solving for angle C. So remember, we are solving for triangle ACB prime. We know angle A. Now we know angle B prime. So let us now solve for angle C. So to solve for angle C, we have C equals 180 degrees minus 120.47 degrees minus 38 degrees. And that will give us a value of 21.53 degrees or 21 degrees and 32 minutes. Now next, let us solve for the missing side. So here we're given side B and this is side A. So this is also 30. So the missing side here is AB prime. So let's try solving for AB prime. To solve for AB prime, we can use this proportion, sine C, sine of this angle C, over its opposite side, which is AB prime, equals sine A over the opposite side of sine A, which is side A. Okay. Substitute the values, we will have sine 21.53 degrees over AB prime equals sine of 38 degrees over 30. Therefore, AB prime will be equal to 30 times sine of 21.53 degrees all over sine of 38 degrees. That will give us 17.88. So now we were able to solve for triangle ACB prime as well. Now, this is also another case that may appear under this case 2 or SSA case. Now let's go to case 3. So here, let A be equal to 45. Angle A is 38 degrees and side B equals 42. Now with C as the center and 45 as radius, draw an arc. So we have this figure. So angle A is 38 degrees, this angle. This is side B, 42. This is side A, 45. Now with C as the center, so this point C as the center, and 45 as radius, so this is a radius, 45, with 45 as its length. This is also, alright, so with C as the center and 45 as radius, draw an arc. So this is the arc. Now notice that this arc intersects the second side of A at 2 points. Now this is the second side of A. Okay, so the arc intersected the second side of A at 2 points. What are those 2 points? Points B and B prime. Okay, but triangle ACB prime here is not a solution as it does not contain a 38-degree angle. Now notice that in the given, take note that angle A is 38 degrees. So this is 38 degrees. But this angle A here will not be 38 degrees. Obviously, this is more than 38 degrees. This is an obtuse angle. So let's try to solve for this triangle ACB. Okay. So using sine B over B equals sine A over A, we will have this if you substitute the given values. So sine B will be equal to 42 sine A over 45. That will be equal to 0.5746. Now, to solve for B, remember in our bridging lessons, to solve for the angle B here, we will use the inverse function. So B will be equal to sine inverse of 0.5746. That will be 35.07 or 35 degrees and 4 minutes. To solve for angle C, that will be 180 degrees minus 38 degrees, this is angle A, plus 35.07 degrees, which is angle B. Therefore, angle C will be equal to 106.93 degrees or 106 degrees and 56 minutes. So in this situation, in this case, since only this angle A is 38 degrees, then only one triangle exists here, which means that there's only one solution, and that is this triangle ACB. This triangle ACB prime is not a solution because it does not contain the 38-degree angle here, right? Now let us go to case 4. So let us go to this case number 4. Let A be equal to 25.86. So this is A, 25.86. Angle A is 38 degrees and side B equals 42. So this side B is equal to 42. With C as center, so assuming this point C is the center of a circle, and 25.86 as radius. So from the center, going here, this is the radius, and that is 25.86. Draw an arc. So here is the arc. Now notice here that the arc touches the second side of A. Okay? So this means that the radius is perpendicular to the second side of A, which means that angle B here is 90 degrees. So if B is 90 degrees, then angle C will be 52 degrees. Now notice that since angle B is 90 degrees, therefore here we were able to form a right triangle. Since this is a right triangle, so you can solve this using your Pythagorean theorem or SOHCAHTOA. Now also here in this case, since one triangle is formed, therefore it means that there will be one solution in this case. Now if you try using the law of sines in case 1 without constructing the figure, you will obtain, so remember case 1, you will obtain, so if we use this proportion or this formula, sine A over A equals sine B over B, then sine B will be equal to B sine A over A. So sine B will be equal to, in case 1, B is 42, so 42 sine of 38 degrees, the given angle A there is 38 degrees, all over 20, side A there is equal to 20. And then solving further, this will give us a value of 1.29 for sine B. So take note, sine B will be equal to 1.29. Now, since the sine of an angle cannot be more than 1, notice that here sine of angle B is 1.29 and this is more than 1. Okay? So since the sine of an angle cannot be more than 1, then the result indicates that there is no solution. So from here, you can now conclude that there will be no solution because the value of sine B is greater than 1. Okay? So the law of sines is used for what is called the SSA case in geometry. Now, the results above indicate that given two sides of a triangle and the angle opposite one side, if a triangle is constructed using the given parts, three possibilities may result. It can be that one triangle is formed, or two triangles are formed, or no triangle may be formed or constructed at all. Now, it is for this reason why SSA is called the ambiguous case and is not used for congruence. Now, here's a table for the SSA possibilities for the ambiguous case. So, I'd like you to just take note of this. So, here you are on the column here on the left. So, here are the cases wherein you will be arriving at one solution. So, in this first illustration, if angle A is an acute angle, so you're given an angle A that's an acute angle, and side A is greater than or equal to B, then there's exactly one solution. So if this is the case, you have an acute angle A and side A is greater than or equal to side B, then you will be able to arrive at one solution. Also, if angle A is acute, side A is less than side B, and A is equal to B sine A, you will also be arriving at one solution. And another case here is when angle A is an obtuse or a right angle. So here, angle A here is obtuse. Here, angle A is a right angle. And A is greater than B. So side A is longer than side B, as you can see in these illustrations. Then you will also have exactly one solution. Now, when do we arrive at two solutions? When will there be two solutions? If angle A is an acute angle, A is less than B, and A is greater than B sine A. So kindly take note of this. This has been corrected in your learning package already. Now, if angle A is an acute angle, A is less than B, and A is less than B sine A, then there will be no solution. So here, class, A is greater than B sine A. Here, A is less than B sine A. That's why here, there will be no solution. Another case wherein we will not have any solution is when angle A is an obtuse or a right angle and side A is less than or equal to side B.